Right, we're taking a look at the quotient rule. So the quotient rule is we're going to take the if I have two functions being divided by each other, so f and g, I take the low function and multiply it by the derivative of the high. So we call that the low function times the derivative of the high, minus the numerator's function divided by the derivative of the low function, all over the low squared. So let's go ahead and start. Okay, I'm going to label the top as u, is 5x minus 2, that's my high. My low is x squared plus 1. So the derivative of the low with respect to x is 2x, and the derivative of the high with respect to x is 5. So we say low d high minus high d low. So low d high minus high d low. I like to put it in parentheses. All over low squared. Okay, so I get y prime is equal to, the low is x squared plus 1, and times my high, so my low times my high, which is 5, minus my high, which is u, so 5x minus 2, times the derivative of v, so 2x. All right, all over my low squared, which is x squared plus 1 squared. I wrote something down wrong on my notes. It's all good. All right, so y prime is equal to 5x squared plus 5 minus, let's see this, minus 10x squared. The negative times the negative is going to give me a positive 4x, all over x squared plus 1 squared. Combine our terms, we get negative 5x squared plus 4x plus 5 all over x squared plus 1 squared. All right, let's move on to the next one. You try. The next one, I'm definitely going to rewrite this as 3 minus x to the negative 1 power all over x plus 5. My high is 3 minus x to the negative 1, and my low is x plus 5. So the derivative of the higher function u, or is, that's the derivative of 3 is a constant, so I get positive 1x to the negative 2. The derivative of v with respect to x is 1. So we're going to start low d high, okay, low d high. So f prime of x is equal to our low, which is v, d high, times x to the negative 2, minus high, d low. 3 minus x to the negative 1 times 1, all over x plus 5 squared, low squared. We can simplify. So f prime of x, that's cray looking. Let's try that again. F prime of x is equal to, I'm going to move the x to the negative 2 to the denominator of both terms. So I get x over x squared plus 5 over x squared minus 3 plus 1 over x. Yes, all over x plus 5 squared. All right, simplify some more. I get 1 over x plus 5 over x squared minus 3 plus 1 over x over x plus 5 squared. I guess I could have done that a little better. Okay, x prime of x is equal to 2 over x plus 5 over x squared minus 3 over x plus 5 squared. Cool. It's not pretty, but it's something. Okay. Let's go ahead and move on to being a little crazy here. Number 3. So we're going to find the derivative of tangent. We're going to derive this, and then from here you can memorize it. Okay. So remember, what is tangent but a quotient? It is the sine of x over the cosine of x. So we're going to make u is equal to sine and v is equal to cosine. So u is equal to the sine of x and v is equal to the cosine of x. Du dx is equal to cosine x. The derivative of v with respect to x is negative sine x. We start f prime of x is equal to low d high. So cosine of x times the cosine of x minus high d low. Sine of x times negative sine of x over low squared. Cosine x squared. So f prime of x is equal to cosine squared x plus sine squared x all over cosine squared x. And that is equal to, all right, cosine squared x plus sine squared x, Pythagorean theorem, that is 1, and over cosine of x, cosine squared x, reciprocal identity giving us secant squared x. So long story short, the derivative of tangent is secant squared x. We can derive any of the trig function, the derivatives of the trig functions using the quotient rule. All right, so let's have a little review here. Sine, reciprocal of sine is the cosine of x. The reciprocal of cosine is sine, the reciprocal of cosine is secant x, and the reciprocal of tangent is cotangent of x. Sorry, I messed up here. 1 over sine is not cosine. 1 over sine is cosecant of x. And cotangent is equal to 1 over tangent, or what? Cosine x over sine x. And then just our regular Pythagorean theorem, sine squared plus cosine squared is equal to 1. All right, so the derivatives of each of these trig functions are sine of x is equal to the cosine of x. We know that one. The derivative of cosine is negative sine x. Derivative of tangent we just learned was secant squared x. Cosecant's derivative is negative cosecant x tangent x. And secant's derivative is secant x tangent x. And cotangent's derivative is negative cosecant of x. Sorry, cosecant squared x. All right, so you're going to have to know those. You're just going to have to memorize them, okay? If you have some good memorization tool, let me know. All right, we're going to take the derivative of 2x minus tangent. So do I need to use any crazy rules here? Nope, I can use the power rule here. So the derivative of 2x is 2. And then the derivative of negative tangent is basically negative 1 times tangent. So I have negative 1 times the derivative of tangent is secant squared x. So I get y prime is equal to 2 times negative secant squared x. Number 2, I have 1 minus cosecant of x. Oh, I forgot. This also needs a secant x. I didn't fix that on the template, but I will before you print it. All right, so we have 1 minus cosecant x over secant x. So I'm just going to go ahead and use the quotient rule here. So I have u and v. So u is equal to 1 minus cosecant x, and v is equal to the secant of x. Do you have to write out these u's and v's? No, but if it helps you organize, then that's cool. Okay. Du over dx is equal to, the derivative of 1 is 0. The derivative of cosecant x is negative cosecant x cotangent x. So the negative 1 comes down. And then the derivative of cosecant x is negative cosecant x cotangent x, which just gives us cosecant x cotangent x. All right, the derivative of secant x is secant x tangent x. All right, so we're going to go ahead and use the quotient rule to take the derivative. So f prime of x is equal to low d high, high d low. So the low is secant x, right there, secant x, times the derivative of the high. So, which we figured out is cosecant x, cotangent x, minus high d low. So 1 minus cosecant x times the derivative of the low, which is secant x tangent x, all over the low squared. Secant x squared. I can see right now that this cosecant, the secant squared x is going to divide out of my two pieces here. So I'm going to divide it into here, and I'm going to divide into here, giving me f prime of x is equal to, basically that's going to go away. So cosecant x times the cotangent of x minus 1 minus cosecant x times tangent x all over secant x, and that's fine. Okay, last one. Sine x tangent x. Sine x tangent x, there's a lot of ways to solve this one, but because I just have two trig functions being multiplied together, I am just going to use the product rule to take the derivative. So u is sine and v is tangent. So u is sine x and v is tangent x. Du dx, so the derivative of sine is cosine of x, and the derivative of tangent is secant squared x, which we just found out. So we go, the derivative of the left, sorry, the right times the derivative of the left. So tangent x times cosine x plus right, sorry, I might have said those backwards, but because it's plus, it doesn't matter which way we write it. So sine of x times the secant squared x. And we can just do a little bit of simplifying, I suppose. So we get sine x over cosine x times cosine x plus sine x times 1 over cosine squared x. Those cancel, giving me y prime. That was a real big bad, sorry. Y prime is sine x plus sine x times secant squared x. And that's pretty much as good as we can get. Guess you can factor out a sine x if you want, but it's all the same. All right, chillin'. That's it for this one.